Hello everyone. Well, today I want to talk about neon bulbs. This little neon bulb. It's just a little glass envelope with neon gas inside, two little wires sticking up inside. I guess you'd call them electrodes, and a couple of wires coming out the bottom that you could fasten onto a power supply to light it up. Now these little guys take 70 volts or above to light. Uh, they'll work fine on 120 volts, AC or DC. You need to put a resistor in series with one of the wires just so it doesn't get too bright and turn black on you. But the things are cheap. They're 35 cents on eBay or Amazon. And if you buy some, buy 10. I mean, it's so cheap, 35 cents. And you need a bunch of them for later experiments I'm going to show you. Now this little guy is still used in little gadgets like this receptacle tester to make sure it's wired right, lights up here properly if it explains it on the little diagram here. Still used in some vacuum cleaners to show you that the dust bag needs to be changed. It'll light up. Still maybe used on some coffee pots. I don't know. But it's a little pilot light device that was cheap, lasted practically forever. Nowadays, they use LEDs because they're pretty cheap too, and you can get all different colors. Years ago, I found an interesting book by General Electric, and it's pretty extensive. Covers all the different types of neon bulbs, has all the specifications, all the voltages. Some neon bulbs were made to light up on a little higher voltage, like 130 volts or so, but most will work 70 volts or above. Well, you need 90 volts. I mean, that's kind of an ideal voltage. And I used to have a 90 volt battery. We'll try to find one today. The old 90 volt batteries were considered like the B battery in a battery operated tube type portable radio. The A battery lit the filaments in the radio. The B battery supplied the plate voltage. It had to be higher, and some worked on 45 volts, some worked on 90 volts, and you could go to the local hardware store and buy a B battery. Well, I had one. I'm not sure where I got it, but I had it, and I used it for years just to experiment with neon bulbs. Well, since you couldn't buy them today, or at least I couldn't find them using the internet, I decided I'd just make a pretty good power supply, a DC power supply, and I wanted it well filtered for future experiments, because I'll whet your appetite just a little. You can get some of the most amazing sounds out of a neon bulb. Things you wouldn't believe until I show you. But anyway, today I'll show you what I made. I just took a block of wood, and I made a power supply. I had all the parts from my boxes of junk and my junk boxes, and I just had parts, and I just put them together on this little board, which is about what, 6 inches or so by 6 inches, and took longer to screw everything down on here than it did to connect the parts up. But anyway, it's pretty simple. Has an input transformer. It has a fuse. Has a little reactor here for additional filtering. Some big filter capacitors. another filter capacitor here, a couple of resistors, and then it has a couple of little, has a capacitor here and a resistor here, which are, and I'll show you on a diagram. Let's get the old diagram out here. That's the resistor, that's the capacitor. And this makes, there's a neon bulb, that's the correct symbol. Put a dot in there, show that it has gas inside. These two components causes this neon bulb to be a relaxation oscillator. Relaxation oscillator. Now this is an NE2 that I'm using. They also, and another popular bulb is NE51. Well, I didn't happen to have any extra NE51s. They sort of look like this, more like a regular pilot light. They have a bayonet base that hooks into a socket, and they're a little more expensive. But you really don't need those. You can just use the NE2s. So anyway, back to the diagram real quick. My power supply, ACN, fuse, transformer, which is pretty much a 120 volt to 120 volt, a rectifier diode, filter capacitors, there's a reactor in there, kind of smooths everything out, a resistor, another capacitor, and a bleeder resistor, so when I unplug it, all the voltage kind of dies off. That's so I don't get shocked. So, but anyway, it's real simple, but it puts out a little more than 90 volts, but it's not real critical. It doesn't have to be 90, it could be 100, it could be 130. It's not that critical. So what happens is the relaxation oscillator, the reason I wanted to use that, if I can get this all untangled here, reason I wanted to use that is I wanted a good visual indicator that the neon bulb was indeed lit, easy to see, even in the bright lights of the room. Let me plug it in. Now, believe it or not, it actually is plugged in. And this other wire coming off the end is about a 6-foot piece of 2-conductor wire, about 6 foot. And it's not a critical length, but it ought to be 6 or 7 or 8 or 10 or something like that. A little bit longer. Okay, so finally, on the end of that, and since I've got the relaxation oscillator built right onto my board, I put a little connector on here and was able to stick the neon bulb on there. And on the other end of my 6-foot piece of wire, I have another neon bulb with a little connector there just to make it easy to hook it up. And you see the little neon bulb blinking there? See it blinking? That's due to these two components, the capacitor and the resistor. Now the resistor is really high. In my case, it's 2.7 megohms, 2.7 meg. Okay, a red, violet, and blue bands on the resistor. My capacitor is 0.27 microfarads. And there again, they're not critical. It could be 0.5, 0.33, you know, fairly big though, and a fairly high resistance. That makes the neon bulb really happy to be a good relaxation oscillator. The other end now, you notice what happened. This one is lit. and the other bulb is in parallel with it. So they're both hooked to the same source. One's flashing, one's not. Now the interesting thing about it is, I don't know if I can hold all this at once. These bulbs are pretty closely matched. In other words, the internal wires inside the glass envelope, they're spaced about the same apart. About the same amount of gas in each. And by experimenting with, this is why you need more than one neon bulb, by experimenting with these bulbs, you try to get them matched as close as you can. And when I say matched, I mean, if this one's not lit and this one is lit, or vice versa, just get your finger near the other one. Too many things. Let me set this down here. I got too many things in my hand. If they're closely matched, you notice I just lay my finger on the glass and it starts, this one now is flashing, the other one is not. When this one's flashing, the other one is not. Now what you've made, if you build something like this, is a real sensitive, and if you try to get these matched really close, it gets really sensitive to the point that you have almost made like a Geiger counter. It's picking up stray electrons out of the air, and you can take, and this is a little hard to believe, but you can take a rubber band, stretch it out, rub it on your clothes, flip it with your finger at one of the bulbs, and it'll cause it to flash. The stray energy off that rubber band will fly across the room and light that bulb. It also, I've noticed once in a while, it'll just flicker on its own. I'm not sure if that's a gamma ray doing that or what it is. Also, I have some radioactive rocks. They're low concentration, of course, and I keep them wrapped in tin foil and in a metal can. But I have some radioactive rocks that was mined out in Moab, Utah. You can put the rock down near the bulb and it'll also light. And I guess it's due to the radiation from the rock. Now you can put magnets near it, doesn't do anything. Use a magnifying glass, you can try all kinds of stuff. And you'll just have to experiment yourself and see what a remarkable device this neon bulb is. And if you get these bulbs matched pretty close, and you can keep experimenting. That's why I used the type of connector I did, because it's easy to change. Just unscrew a couple of screws, stick another one in there, and tighten them down. You can get it so sensitive. And I had this happen once years ago. I had it all set up on my workbench. I was 10 feet away on the other end of the workbench. Masonite top on the workbench. Nothing conductive. I had it so sensitive. The bulbs were so closely matched. I could just touch my finger to the masonite top on one end of a 6 or 10 foot workbench, and the bulb would light on the other end. I know it's hard to believe, but you really can get it sensitive. Now, after a while, when it runs for hours and hours, the sensitivity kind of dwindles and they're not as matched as good, because whichever one is flashing the most, it's breaking down or boiling off electrons or whatever it's doing. Anyway, they become unmatched. So it takes some playing around with it, experimenting with it, and I think you will find it quite fascinating. Maybe next time we'll talk about how you can get sound out of a neon bulb. You just won't believe it. Thank you for watching.